Hello, Himitsu here. My hair failed, but I'm still going to do the review because it's not about me. Today I'm going to do the review on MKey Squonker by SubMonkey mode. I wrote a script about a year ago, but I was too hesitant to make a review for it, which I'm going to detail more later. There will be some interesting topics I would like to cover with this review. First, why do we squonk? When there are other options like dripping or using RTAs. I talked about this a bit in my NarDA review, so I'm just going to point out some pros and cons of each system in more detail. Second, DNA versus Dicodes, which are both specialized for accurate temperature control vape. From the comments I received from the past videos, I realized not many people are using the TC mode anymore, even though I wrote a very detailed script for it. Since there weren't many interests in this subject, I decided to compromise and point out just one strong point of TC this time. Because speaking about Dicodes board without talking about temperature control at all feels like missing out. Third, why I was so hesitant to make this review, which took me a year to make a decision. Enough said, let's dive into it. Here's the mechanical 18650 squonk mode. When I press the fire button, it produces a very clean, constant output throughout, and how the wave feels is the smoothest throughout the draw. The temperature I feel is very even. The drawback is that the output decreases continuously as the battery is exhausted. For example, let's say if you happen to like the vape at the nominal voltage of 3.6 volt, that just goes away very quickly. That's why I prefer this regulated squonker. Now, here's MKey Dicodes squonker for today's review. You just saw how crazy the size is with a regulated chipset inside. Their sizes are very similar, which is very impressive. Speaking of the Dicodes board, it is known to be very precise. It does what you want. For example, you set the power and the board pins down the exact output for hitting the coil. Therefore, if I vape with the Dicodes mode, it also provides a smooth and even hit. Now, here's another squonker I use, Club V2 with the DNA 75C chipset. Even though it is extremely well built, which results in me using it the most out of all squonkers, I have to say that the output is relatively wonky over time. Using power mode, at first, the output increases smoothly, which you all probably notice using DNA modes. It is actually a good compromise to optimize battery efficiency, but after the smooth increase, the output feels uneven, and the juice seems to pop more, compared to Dicodes and mechanical modes. Especially when the cotton is dying or needs to be replaced. The constant output is actually very important because it can affect the longevity of your build. Otherwise, there can be overheating of the coil as well as underheating like a ripple. So vaping DNA chipset feels like having more of a ripple with a smooth increase in the beginning. You may not notice that though, unless you enjoy vaping like me drawing more than 8 seconds. Some people say that DNA hits slightly harder than the set power, as if the board was calibrated to cover the possible losses in the circuit. Because what you see on the screen is actually not the number that goes to your coil, but rather how much power is used in the circuit. That's why I always tell people to believe in their taste rather than the number on the screen. I will cover more of that later. On the other hand, Dicodes chips are known to produce the most accurate performance for temperature control. I've never had issues with DNA for TC though, so for me personally, the main advantage of Dicodes is the quality of signal flow. What do I mean by that? The satisfaction of hit I experience is in this order: mechanical mode and Tesla Invader 3, MKey, and then Club V2 and Hades, Tesla chip, Dicodes, DNA. I put in order for the quality of signal flow. If you've ever used Tesla modes, you should have observed that your vaping experience is like using a mechanical mode with a steady voltage output, because the mechanical modes are subject to the voltage drop continuously, as the battery discharges. Since some people asked me about Tesla chips in the comment for my previous NarDA review, I also attached a screenshot of my reply explaining why they seem to get a better vape experience with them. Please pause if you want to have a read, as I also discuss a little about the DNA board. So for me, the Dicodes gives a similar vape experience as Tesla on a variable wattage basis. Then what's good about DNA boards? The first thing is the easiness of use with their great graphical interface. I think this is very important because most of us just want to put the atomizer on top, adjust the power, and vape. Secondly, they use great components for their boards. One day, I disassembled to fix my old Paranormal. I realized they used the Geometry Cell balance control chip from Texas Instruments, who produce one of the highest quality semiconductors. Their quality control is second to none, and it was great to see that in the DNA board itself. Thirdly, with their Square software, you can customize however you want. So it's like Apple and Android. Using Dicodes, there's a learning curve, so if you first use it, it wouldn't be very obvious how to go through the menu system inside. There is also restriction of customization, but very efficient, like using Apple. Using DNA, you can make your custom themes, so many different options, but you should really know what you're doing, like using Android. So between the Dicodes and the DNA, it should all depend on what you need, whether you prefer to have an instantaneous and efficient quality of vape with a less obvious menu system, or you like to maximize the different options with a more intuitive menu system along with the great software, eScribe. Honestly, it's such a sophisticated advanced board that I do not have knowledge enough to comprehend everything yet. I always hear Dicodes is better than DNA, but it's just all your preference. And Evolve, the company who makes DNA chips, was a pioneer of the first wattage control device with a graphical screen, if you remember Darwin mode, also temperature control and replay. As one of the nerdy vapers, I'm always excited to see how Evolve brings new features to the vape scene. Since it's mentioned, let me tell you a little bit of background about temperature control vaping, because these boards were popularized by their accurate TC. Temperature control started when there were studies of the danger of formaldehyde, which is actually Dalin, like what you see here. And everybody started to worry about dry hits or burnt wicks, etc. Evolve realized that the problem was overheating. Therefore, they made it so that the coil doesn't overheat. But the temperature control is very fiddly, because even though you think you know all the parameters that are involved, there are still things out of your control. For example, we care about the material of the wire and the TCR, but in reality, the board only knows what's going on between the terminals. So the current goes through the wiring, the 5-pin connector, the center pin, the post, and the coil, and comes back again, etc. So even if the board is perfectly capable of doing temperature control well, if there are manufacturing inconsistencies, it's not working great as well. And also your atomizer, which is made out of stainless steel, builds up an oxide layer which causes the resistance to change over time. I guess that is the reason why the temperature control vape has fallen out of fashion, not to mention users' errors. Evolve kind of sorted that issue by introducing replay though, but it's a different thing. I also wrote a detailed script about how the smooth power increase happens in the DNA circuits and why we have a variable wattage in TC mode, but I omitted them because of the length of the video and lack of interest in TC. You'll be able to find them in my Patreon. Briefly, the thermal is good for battery efficiency and longevity of electrical components, and the latter is useful for tweaking which layers of your juice you like to fill over time. Enough said about the differences between chipsets, let's go back to the Squonk system. This Black Club has the Squonk tube, like this Hades that I love, and the battery contacts are very well built. Battery contact. When I talk about the mode, I keep emphasizing that the battery terminal is the most important part, as that is where current starts and ends. But this M key doesn't have a stable battery contact. There is also an issue with this mechanical mode, which has a fixed contact for a larger surface area, something like this. Even though M key tried using a rubber foam under the negative contact, It will wear off over time and lose the tension. Then you have to replace the rubber, so you'd have to deform this battery contact while lifting it, which may break it. Plus, when my mode arrived, there wasn't a rubber spacer installed, so it couldn't grip my 18650 at all. So what you see is what I installed. Yeah. But still, the battery started to rattle inside after 8,000 cycles. Something like this. So I just have to replace once again. So I hope the negative contact could be redesigned or made thicker and stiffer, like Billy Club V2, so that the battery sits against the tension of the metal contact rather than the tension of the rubber spacer. Even though my Billy Club has an issue with ripping off my battery wraps, I can just easily change them. So this is probably the biggest con, I should say. The battery contact always has to be stable and solid. Otherwise, it can have a power loss, scratch your battery terminals, or in the worst case scenario, cause a spark. To have the full potential for great chipsets like Dicodes, I believe how the battery contacts are designed is the first crucial step. For example, this old mode, Tesla Invader V3, well, you may say, oh, it is made in China, but this mode design actually surprised me a great deal when I disassembled it. Inside the battery housing, it has a seesaw-like structure to equally distribute the tension between the two batteries for increasing the surface area. Such a simple mechanism makes a great change. The battery indicator is very nice and clean. Always make sure to wipe your battery contacts clear and also your 510. The 510 connector is inside this hexagonal-shaped printing body, which is a well-designed touch to prevent your 510 from rotating. I think this is the Corsair 510 connector by McGough. The soldering is not great, having sharp edges, but it works. The 0.999 silver was used here, but interestingly though, the current carrying wires from positive and negative are not insulated. This means they're quite oxidized and tarnished, as well as the battery contacts. Since the printing material is an insulator itself, I can understand the design choice though. Silver of course resists oxidization, but when silver meets sulfur, the story goes awry. When it reacts with sulfur in the atmosphere and becomes tarnished, the conductivity drops badly. For this reason, high-end audio terminals sometimes plate with gold, which has a lower electrical conductivity than silver but doesn't corrode. Plus, plating with rhodium to prevent abrasion. And here you can find a clever choice to make such a small size mode, since the printing is done to house the inductor of Dicodes BF60 chip, which is located between your squonk bottle and the 510. A beautiful location indeed. It is actually more surprising with this compact size if you think about the Dicodes board, where they have soldering pads only on the backside, whereas you can solder both sides on the DNA60. In simple terms, it is more tricky to wire Dicodes board most of the time. The 510 is adjustable and it is raised by rotating clockwise. Personally, I remember this as the direction of back electromotive force, if you recall Faraday's law and Lenz's law from your school. For example, I generate the current and the 510 raises in the direction of the back electromotive force. Excuse me for being a physicist. Anyways, there's also another con in the 510 threads, because some of my atomizer threads do not agree with the thread of this one. For example, my Cycra RSA. This is very low, but it just doesn't go in. The maximum diameter without the overhang is 24mm. This loose supersonic is 24mm, so I cleaned my table a bit, so if I just show you my supersonic on top, if you have to manually set the depth of your 510, it's best to pick one atomizer to go with that mode, so you don't have to keep adjusting like me. So 24mm is flush, like this. Here are the dimensions by my caliper, 42.3, 28mm. And the weight without a squonk bottle is 123, without the battery, 77.4 gram. So small and light. In the package, you receive 2 squonk bottles, one black and one white. I also received this door, but there was no magnets attached to it. So, like this. So, it just falls off, which is a pity as it looks very nice. The door printing was not perfectly designed in the way I requested, but it turned out well anyways. You also received this which goes between your atomizer and the mode to prevent scratching the surface of the mode. But I advise you not to use it since having a larger surface area is always important between the atomizer and the 510 connectors. If I fill my squonk bottle, I tend to put the squonk bottle with the logo visible from the door cutout as I found that it is more squeezable in this configuration. The door closes on a rail, but it rattles slightly due to the fundamental nature of 3D printing. There are always tolerance variances. Also, you get the certificate, sticker, and the usual thing from your Dicodes mode. One bottle here, and the other bottle was inside the package. It'll take a long time to detail the menu system of this Dicodes chip. I instead refer to the BF60 datasheet from Dicodes in the description. It's always great to read the menu for your chipset to understand and pick the best options for you. I will just show you some useful things you may want to adjust. In the main menu, resistance, power, the mode, and the voltage of your batteries either under load or resting voltage. What I mean is, if I fire it, the voltage on the load lowers. If I click twice, in Edge control, the standard is the variable wattage mode, and bypass works like a MOSFET. So basically, it works like a mechanical mode with protection not to over discharge your battery. This can be activated as a setting in the mode menu, extended function, mode menu, export mode. You change from 0 to 1. I used to use this bypass mode because I let it run over different voltages with a fully charged battery. When there's a specific moment I find the taste to be suited to me, I check my wattage, record it, and let it drop the voltage to find another sweet spot. Let's say I like the vape from 33 watt. And then with my new battery I go to the standard mode, and I set my wattage to like 33 watt. That's how I actually set my wattage as 27 watt for my NarDA build, as in my previous NarDA review, since I use Hellfire Shadow Dicodes Squonker for years. I won't cover the extension function as this would make this video too long and they could be covered by reading the datasheet. For the supersonic, I personally vape with 37 watt for Dicodes chip, so with my build. Now we have covered the design choice and the board, then how well does it do as a squonker? I honestly do not like this traditional bottle system as I'm very used to using this tube system. It's so much easier to refill that way, as in Hades or Billy Club, like this, and you put it in, than this old-fashioned way that M-Key has. And also, I cannot access the board in case the board fails. I'm unsure how the front plate is attached to this device, possibly epoxy, but when I think of the device, there are two priorities. First, how simply they're built together in case the device fails to work. Second, how preferable the chip works in the way I want. There's no complaint when it comes to the Dicodes chip for the second option. For the first option, here's the image of my old Paranormal when I tried to fix some components in the DNA chipset. You can see how many different parts were assembled with all different kinds of screws. I can understand why this company probably did this to prevent users from opening and damaging the mode by disturbing connections, etc. But well, what if the chip itself fails? What if your warranty passes? Since that was a mass production one, some users are more likely to fix their own modes. Therefore, the priority is how easy it is to disassemble and reassemble. For example, I can access to the chipset by just lifting up for these two modes. As a side note, I know there are controversial opinions about dot mode products, even though I do not have one. I had a chance to fix my friend's dual battery mode a few years ago. I was quite surprised how simply it was built with easy access together with good soldering. The simplicity not only makes the modes more accessible to users in case they fail, but also makes the production line more stable. Also, fewer parts are usually better for reducing power loss, as there will be fewer joints between parts. So in my opinion, that mode products are well designed as well. Also the billet box, even though I do not have them, as they do not suit the way I vape. Speaking of the way I vape, we can talk about what's good about Squonking. Then, let's go on top. First, for some people who change their liquids a lot, I just advise them to use RTAs because removing the scent from your squonk bottle requires a lot of work to do. In my case, since the beginning of my vaping, I've had the same liquid for more than 100 bottles. That liquid has given me the reference for all my builds, so my NarDA just happened to give the most satisfying experience for the liquid. But if the liquid is no longer produced, NarDA is no longer my most used RDA anymore. Anyways, use squonkers when you find your favorite liquids or liquids that you at least have for a long period. After you switch to squonking, the pros are, first, you can always vape dry and the spit back is much more reduced. If you drip your liquids through the drip tip, it can adhere and flow on the surface of the chamber, and the liquid can just enter your mouth by suction. This can make you tired of the liquid easily. Second, one of your hands is free, as you don't have to hold a liquid bottle. Third, it's a much faster way to saturate your cotton, as you simply need to press it. Oh, this is empty. For the third reason, the most important factor you have to consider when choosing a squonker is how easy it is to refill the squonk bottle. For the reason, before I started to use these tube systems that I love, I only used Hellfire Shadow, which had an amazing bottle carrier system which took only 30 seconds to refill. For the mainstream gear, I also like Topside. Now I like the tube system of these since it takes less than 15 seconds to refill the whole 8 or 10 ml bottle. If refilling is uncomfortable for the device, I might just as well drip down the straight. Here are a few tips if you decide to squonk. First, having a clear cap is always useful since you can always see the status of your cotton to prevent the possible dry hit and over squonking. Second, the way I like to remove the sand from the bottle is just dip into isopropyl alcohol for about 2 weeks and dry under sunlight. Third, I found the RDA with the hexagonal shape of the bottom pin was always the best rather than something like a flathead bottom pin. Apart from the practical side, we perceive the flavor differently for dripping versus squonking. There are two things. From the first pro that I mentioned about reducing the spitting, it can actually be subjective for some people as they can perceive the liquid coming into their mouth as, oh, more flavor. But personally, that's just not what I want. And if you want to avoid that while dripping, the simple solution would be to use the larger diameter of the drip tip. Secondly, this is more advanced, but if you do squonk, you need to reduce the cotton mass to allow the liquid to flow by fluffing it out. But if you drip, it's mostly better to fill the cotton under the coil and inside the chamber as much as possible to prevent having a wasted space. So in this case, the dripping that eliminates the wasted space tends to be more delicious by making a slightly more reduced chamber. However, this can be improved for squonking as well by the wicking method I presented in my NarDA review. The way I did was purely trial and error, as in I tried pretty much everything to have the maximum inflow of the liquid to the coil. The reason I'm doing that is because the cotton can't stand my way of vaping. If I vape just randomly, since I do not hit the coil up greatly at once, but rather hit gently over medium heat with a lower surface area of the coil while having a longer draw. Oh, I need to see. Oh. By spreading out the layer of the cotton, even though the mass of cotton is reduced, the circumference and the surface area of it is increased, so the overall volume of the cotton is increased inside the chamber to prevent any wasted space. This month, my friend John actually explained as a chemist's point of view for why my way of wicking is actually in favor of increasing the influx of the liquid through the coil. The conversation actually started by me asking why the way presented in YouTube a few years ago was called wick hard. Didn't work. If I turned on the recording of our conversation.
The reason that it doesn't actually work in the way that it seems in the video is because although a larger quantity of cotton allows a larger quantity of juice to flow at any one moment, as it gets constrained by the coil, the surface area is reduced greatly. So capillary action relies on surface area because the molecules of the liquid adhere to the high surface area wicking material. But the surface area is reduced as the cotton is kind of squeezed into the coil. So although a large amount can flow up, it can't then flow into the coil. So what's mainly touching the metal is just cotton. So that will burn much faster than any of the juice can flow from what's been picked up by the wick outside of the coil. So the juice needs a space to flow through inside the cotton, and if you remove all of that space, it doesn't matter how much surface there is for the juice to, in theory, adhere to. It actually can't reach any of that surface because there's just no way for it to get there. It's like if you block up the mouth of a bottle with a piece of cloth. If you have the cloth in loosely, the water will saturate the cloth and then eventually pour out. But if you have it in very tightly, even if the cloth would usually become saturated with water and flow out, it wouldn't, because it was so tight that there's no space for the water to flow through. So you could block the bottle and form a proper watertight seal with just enough cloth stuffed in. So although in this case there's a lot of liquid flowing up through the cotton, it just can't go anywhere. It gets to the coil and gets stuck. So you're increasing the available surface area, even though you're decreasing the total surface area of the cotton. So there's more points for the liquid to adhere to as it travels along the cotton. Less is getting in its way. It's not having to, there's no kind of blockage. At the same time, you're also making all of the cotton threads have a coherent direction. There's more efficient capillary action because as they kind of climb up along the threads of the cotton, searching for a new bit of surface area to adhere to, that direction that they climb along will always be in the correct one towards the coil. So when the juice flows through a big clump of thick, heavy cotton that hasn't been fluffed out at all, it's got lots of places to stick to, but very little space to flow. It's difficult for it to actually move through that material. Whereas if you have fluffed out cotton, you can have as many places which are immediately available to stick to because you've got more parts revealed to the liquid, but there's much less blocking its flow as it goes along.
So that's why removing the clump inside the cotton was actually helpful for reducing the amount of brownish spot.
Yes, because the brownish spots are caused by where it can't flow along and so builds up over time.
So even though without knowing any theory behind, I actually did the correct thing.
Yes.
Over experiments and experiments.
Yeah.
Because what I'm interested in is not to have the most amount of saturation of the cotton. What I'm interested in is the most amount of saturation of the cotton inside the coil.
Yes, because that's the most important part. It doesn't matter how saturated the rest of the cotton is, because the only part which is being vaporized is the part that's inside the coil. Unless you're delivering the liquid efficiently to the coil, it doesn't matter how much you can soak up. It's like sticking an extra sponge in your atomizer. Sure, you can saturate it and soak up extra liquid, but it's not actually doing anything. Yes, that would have been my first. If I didn't know how to do it, and you said, okay, you need to make it so that you'll have efficient delivery of the liquid through capillary action, I'd go, okay, well, I need to increase the surface area. And then I'd go, okay, how can I increase the available surface area? And I'd go, oh, I could put more in there, but if I put more in there, oh, see, it gets a bit tight. So I need it to be as loose all the way through so that it can efficiently flow through the cotton. Oh, I'll fluff it out more. And then I would have gone, this works. There's a point where it won't produce any better results because all of the cotton strands, their surface area is being saturated by adhered molecules of juice. At that point, it doesn't matter how much you fluff it out because it's all coated completely.
Wrapping up, Francesco, the owner of SubMonkey modes, is my good friend. So I was very hesitant to detail all these negative points in the review. I've known that he really wanted to see this review, but I just could not make up my mind for a year. So a very good thing is that he's known to provide excellent customer service, so in case my chipset fails in the future, I'll be easy to send him back for maintenance. Then the second priority I mentioned about being unable to disassemble would be almost no issues anymore. Also, since I designed this pattern, I remember that he wasn't satisfied with the printing quality of this mode when he was making it for me. So he had to print multiple different bodies which would pass his standard. I still remember how thankful I was, and I could see his passion and professionalism. If the quality control and the battery contacts are removed, if the quality control and the battery contacts are improved, it would be a great daily mode to use as well. Refueling is still a classic style, so I use Antiquity RDA the most on top since I did not have to refuel often for MTL atomizers. For example, these pictures are all low wattage vape, Antiquity Fluid, Antiquity V2, NarDA, and NarDA, all low wattage vape. I use NET with temp control because Dicodes is a great chip for TC, and there's something most people are actually not aware of. The temp control has one advantage that can't be imitated by any other methods. The amount of vapor varies depending on the amount of air coming in, like smoking a cigarette. For example, if you don't breathe in fire, 2 watts. If you draw normally, 12 watts. If you draw strongly, 15 watts, because the coil cooling from incoming air is counteracted by temp control. So depending on the amount of your suction strength, the wave changes like a cigarette spark in real time. Very good for NET liquids. So all in all, I'm very happily using this mode when I use the mouse-to-long atomizers, and it's so light. I like 3D printing modes in this respect. Very durable and lightweight. In such a small form factor as well. This M key is by far the smallest Dicodes 18650 Squonker I've found following McGough V2. I honestly wasn't satisfied with the quality of McGough V2 in the past, so I chose M key last year, and I was very happy with it. I have listed some cons throughout this review, so this mode is not perfect, but good, and especially since this pattern was designed by me and Francesco together, it's just beautiful and it holds the sentimental value for me. I'm sure everyone has their own collection, either their watches, shoes, pieces of jewelry, etc. Do you remember how your feeling was like when you first got it? Well, the feeling towards this mode still remains in my heart deeply. Thank you for watching.